Have you ever looked up at the night sky? You see twinkling stars, you might see the moon, perhaps a planet shines brightly. It all seems so far away, doesn't it? But what you see is just a tiny, tiny speck of what is actually out there. The universe is vast. It is bigger than anything you can imagine. It stretches in all directions, filled with mysteries. We live on a small planet called Earth. Earth orbits a star we call the Sun. Our Sun is just one star among billions. And our galaxy, the Milky Way, is just one galaxy among billions, maybe even trillions. Thinking about this can make you feel small, but it can also make you feel incredibly curious, full of wonder for the cosmos. The sheer scale of the universe is something that has fascinated humans for centuries. Ancient astronomers charted the stars. They built incredible structures to align with celestial events. They told stories about the constellations. They tried to make sense of their place in this grand cosmic theater. Today we have powerful telescopes. We have space probes venturing far from Earth. We have complex mathematics and physics. These tools help us peel back the layers of the universe. Yet, with every new discovery, we often find even more questions. The universe doesn't give up its secrets easily. It challenges us to think bigger, to explore further, and to always keep learning about our cosmic home. Imagine trying to count every grain of sand on every beach on Earth. That number would be huge, almost unimaginable. Now try to imagine something even bigger. The universe contains more stars than all the grains of sand on all the beaches of our planet. It's a staggering thought. Each of those stars could potentially have planets orbiting it. Some of those planets might even harbor life. The possibilities are truly mind-boggling. We are just beginning to scratch the surface of understanding this immense reality. The universe is a place of incredible beauty, awesome power, and endless surprises, waiting for us to explore its depths. Our journey to understand the universe is a collective human endeavor. It involves scientists, engineers, dreamers, and curious minds from all around the world. We build on the knowledge of those who came before us. We share our findings and collaborate on new missions. This quest connects us, not just to each other, but to the cosmos itself. When you gaze at the stars, remember that you are part of this grand exploration. You are looking out at the same universe that has inspired awe and wonder for millennia. And there is so much more out there, so much more to discover about our place in this vast, magnificent universe. When we talk about the size of the universe, we often mean the observable universe. This sounds a bit tricky, but it's an important idea. The universe might be infinitely large. We simply don't know for sure. But there is a limit to what we can currently see. This limit exists because the universe has a finite age. It is about 13.8 billion years old. Light, the fastest thing we know, travels at a specific speed. So, light from very distant objects has taken a very long time to reach us here on Earth. We can only see objects whose light has had enough time to travel to us since the universe began. Think of it like this. Imagine you are on a ship in the middle of a vast ocean. You can see out to the horizon in all directions. That horizon is your observable ocean. It doesn't mean the ocean ends there. It just means that's as far as your eyes, or your instruments, can currently detect. The observable universe is similar. It's a sphere around us with Earth at the center. The edge of this sphere represents the maximum distance from which light has had time to reach us in the 13.8 billion years since the Big Bang. Anything beyond that, even if it exists, is currently invisible to us because its light hasn't arrived yet. So, how big is this observable universe? It's about 93 billion light-years across. Wait a minute, you might say. If the universe is 13.8 billion years old, shouldn't the observable universe be 13.8 billion light-years in radius, or 27.6 billion light-years across? That's a great question. The reason it's bigger is because the universe itself has been expanding while that light was traveling. The space between us and those distant objects has stretched. So, an object that was 13.8 billion light-years away when its light began its journey is now much, much farther away due to this cosmic expansion. It's important to remember that we are not at any special center of the entire universe. Every observer, anywhere in the cosmos, would have their own observable universe around them. If there's an alien astronomer on a distant galaxy, they too would see an observable universe stretching out for billions of light-years in every direction from their vantage point. The universe doesn't have a single center in the way a ball does. The Big Bang happened everywhere at once, and space has been expanding ever since. Our observable part is just our current cosmic neighborhood, a bubble of visibility in an ocean that might be far, far larger. To talk about distances in the universe, we need a special unit. Miles or kilometers just won't cut it. They are too small. The numbers would become ridiculously large and hard to manage. So, astronomers use a unit called a light year. A light year is not a measure of time, even though it has year in its name. It's a measure of distance. Specifically, it's the distance that light travels in 1 year. Light is incredibly fast. It travels at about 186,282 miles per second, or roughly 299,792 kilometers per second. Nothing in the universe can travel faster than light through a vacuum. It's the ultimate cosmic speed limit. Let's try to grasp how far a light year is. In 1 second, light can travel around the Earth more than 7 times. That's incredibly speedy. Now imagine light traveling for an entire year. That's 365 days, each with 24 hours, each hour with 60 minutes, and each minute with 60 seconds. Multiply all that by the speed of light, and you get a very big number. 1 light year is approximately 5.88 trillion miles, or about 9.46 trillion kilometers. That's a 6 followed by 12 zeros in miles. It's a distance so enormous that our everyday experiences can't really help us picture it. Even the closest star to our sun, Proxima Centauri, is about 4.24 light-years away. This means that the light we see from Proxima Centauri tonight actually left that star over 4 years ago. When we look at objects in the distant universe, we are literally looking back in time. If we see a galaxy that is 10 billion light-years away, we are seeing it as it was 10 billion years ago. The light from that galaxy has been traveling through space for 10 billion years to finally reach our telescopes on Earth. This time travel aspect is one of the most fascinating things about studying the cosmos. So when we say the observable universe is 93 billion light-years across, we are talking about a truly mind-shattering distance. It's a distance that light itself, the fastest thing there is, would take 93 billion years to cross. Using light years helps astronomers keep the numbers manageable. But more importantly, it connects distance with time. It reminds us that observing the universe is like looking through a cosmic history book. The farther we look, the deeper we peer into the past, witnessing the universe as it was in its youth, long before our Earth even existed. Understanding the sheer size of the universe can be very difficult. Our brains are not really wired to comprehend such vastness. So, astronomers often use analogies to try and bring these cosmic scales down to a more relatable level. These analogies can help us get a tiny glimpse of just how big everything out there truly is. Let's try a few. Imagine our sun, the star that gives us light and warmth, is shrunk down to the size of a grapefruit. On this scale, the Earth would be about the size of a tiny grain of sand, orbiting about 50 feet away from the grapefruit sun. Now let's extend this analogy. If our sun is a grapefruit, the nearest star system, Alpha Centauri, which includes Proxima Centauri, would be another grapefruit located about 2,500 miles away. That's like one grapefruit in New York City and the next one in Los Angeles. And that's just our closest stellar neighbor. Our entire Milky Way galaxy, which contains hundreds of billions of stars, grapefruits in this analogy, would stretch for tens of millions of miles. It would be an enormous disk of grapefruits, so vast it would dwarf our entire planet even in this scaled-down model. This helps to show how isolated star systems are, with immense voids of space between them. Let's try another popular analogy. Imagine the entire observable universe is shrunk down so that our Milky Way galaxy is the size of a dinner plate. On this scale, our entire solar system, including the sun and all its planets, would be smaller than a single atom. You wouldn't even be able to see it without a super powerful microscope. And how many dinner plates, galaxies, would there be in this scaled-down observable universe? There would be hundreds of billions of them, perhaps even trillions, scattered throughout a volume larger than a giant stadium. Each dinner plate would be another galaxy, teeming with its own billions of stars. These analogies are not perfect, of course. The universe is far more complex and wondrous than any simple comparison, but they serve a crucial purpose. They help us to begin to grapple with numbers and distances that are otherwise just abstract figures. They highlight the incredible emptiness of space, punctuated by these islands of matter like stars and galaxies. They can also evoke a sense of humility. In this vast cosmic ocean, our Earth is a precious tiny blue marble, Understanding these scales can make us appreciate our home planet even more, and it fuels our desire to explore what lies beyond our immediate cosmic neighborhood. Section 5. Islands of Light, the realm of galaxies. The universe is not uniformly filled with stuff. Instead, matter tends to clump together due to gravity. These clumps form gigantic structures called galaxies. A galaxy is a massive system of stars, stellar remnants, interstellar gas, dust, and dark matter, all bound together by gravity. Our own solar system is part of the Milky Way galaxy. When you look up on a very dark night, away from city lights, you might see a faint milky band stretching across the sky. That band is the combined light of billions of stars in our own galaxy, seen from our position within one of its spiral arms. It's a breathtaking sight. Galaxies come in many shapes and sizes. Some are beautiful spiral galaxies like our Milky Way or the nearby Andromeda Galaxy. These have elegant arms coiling out from a central bulge. Others are elliptical galaxies, which are more like giant fuzzy footballs or ovals, often containing older stars. Then there are irregular galaxies which, as their name suggests, have no distinct shape. They can look chaotic, perhaps as a result of collisions or interactions with other galaxies. Each type tells a different story about its formation and evolution over billions of years. How many galaxies are there in the observable universe? For a long time, astronomers estimated around 100 to 200 billion galaxies, but more recent studies using data from telescopes like the Hubble Space Telescope suggest this number could be much higher. Some estimates now point towards possibly 2 trillion galaxies in the observable universe. Each of these galaxies can contain anywhere from a few million to trillions of stars. Think about that. Trillions of galaxies, each with billions or trillions of stars. The number of stars in the universe is truly astronomical, far exceeding the number of grains of sand on all of Earth's beaches. Our Milky Way galaxy is a fairly large spiral galaxy. It's estimated to be about 100,000 light-years across. Our Sun is located about 27,000 light-years from the galactic center, in one of the spiral arms called the Orion Arm. It takes our solar system about 230 million years to complete one orbit around the center of the Milky Way. The closest large galaxy to us is the Andromeda Galaxy, which is about 2.5 million light-years away. It's actually on a collision course with the Milky Way. But don't worry. This cosmic smash-up won't happen for another 4.5 billion years or so. It will be a spectacular slow-motion event. Section 6. Stellar Nurseries and Fiery Furnaces, the Lives of Stars. Stars are the building blocks of galaxies. They are the luminous engines that light up the cosmos. A star is an enormous ball of hot, glowing gas, mostly hydrogen and helium. The immense gravity of a star crushes its core, creating incredible pressure and temperature. This intense heat and pressure trigger nuclear fusion. In this process, hydrogen atoms fuse together to form helium, releasing a tremendous amount of energy in the form of light and heat. This is what makes stars shine. Our own sun is a perfect example of a star, providing the energy necessary for life on Earth. Stars are born in vast clouds of gas and dust called nebulae. These are like stellar nurseries. Gravity slowly pulls material together within these clouds. Dense clumps begin to form and contract. As they contract, they heat up. Eventually, the core becomes hot and dense enough for nuclear fusion to ignite. A new star is born. Stars come in many different sizes, colors, and brightness levels. Smaller, cooler stars are reddish, like red dwarfs. Medium-sized stars, like our sun, are yellowish. The largest, hottest stars are bluish-white. These massive stars burn through their fuel much faster than smaller stars. The life cycle of a star depends heavily on its mass. Smaller stars, like red dwarfs, can live for trillions of years, slowly sipping their hydrogen fuel. Stars like our sun have a lifespan of about 10 billion years. Our sun is currently middle-aged, about 4.6 billion years old. When it runs out of hydrogen fuel in its core, it will expand into a red giant engulfing the inner planets, possibly including Earth. After that, it will shed its outer layers, forming a beautiful planetary nebula, and its core will shrink down to become a white dwarf, a dense, cooling ember. Massive stars have much more dramatic ends. They live fast and die young in cosmic terms. After only a few million years, they exhaust their fuel. Their cores collapse catastrophically, triggering a gigantic explosion called a supernova. A supernova can briefly outshine an entire galaxy. These explosions are incredibly important. They scatter heavy elements forged in the star's core and during the explosion far out into space. Elements like carbon, oxygen, iron, everything heavier than hydrogen and helium are created in stars and dispersed by supernovae. These elements then become the building blocks for new stars, new planets, and even life itself. We are literally made of stardust. Section 7. Worlds Beyond, the Abundance of Planets. For a long time we only knew of the planets in our own solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These worlds are incredibly diverse, from the rocky inner planets to the gas giants and ice giants in the outer regions. Our solar system seemed unique, a special place with our life-bearing Earth. But astronomers have long suspected that other stars must have planets too. If our Sun, a rather ordinary star, has a retinue of planets, why wouldn't other stars? It seems statistically likely, given the sheer number of stars out there. In recent decades, our ability to detect these exoplanets, planets orbiting stars beyond our Sun, has exploded. Using clever techniques like the transit method, watching for a tiny dip in a star's light as a planet passes in front of it, and the radial velocity method, observing the slight wobble of a star caused by an orbiting planet's gravity, astronomers have discovered thousands of exoplanets. Telescopes like NASA's Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, or TESS, have been incredibly successful in this hunt. We now know that planets are incredibly common in our galaxy. The diversity of exoplanets discovered so far is astounding. We found hot Jupiters, giant gas planets orbiting very close to their stars. We found super-Earths, rocky planets larger than Earth but smaller than Neptune. We've even found planets orbiting two stars, circumbinary planets, and rogue planets that wander through space without a host star. Some exoplanets orbit within their star's habitable zone, the region where temperatures could allow liquid water to exist on the planet's surface. Liquid water is considered a key ingredient for life as we know it. The search for Earth-like planets in habitable zones is a major focus of exoplanet research. Based on current data, it seems that on average there is at least one planet for every star in the Milky Way. Since our galaxy has hundreds of billions of stars, this means there could be hundreds of billions of planets in our galaxy alone. And remember, there are trillions of other galaxies out there. The total number of planets in the observable universe is almost incomprehensibly large. While we haven't found definitive proof of life beyond Earth yet, the sheer number of potential worlds makes the possibility seem ever more plausible. The universe is teeming with planets, each a unique world with its own story. Section 8. An ever-expanding stage, the growing universe. One of the most profound discoveries in the history of astronomy is that the universe is expanding. This wasn't always known. In the early 20th century, most scientists, including Albert Einstein, believed the universe was static, unchanging in its overall size. However, in the 1920s, astronomer Edwin Hubble made groundbreaking observations. He studied distant galaxies and noticed something peculiar about their light. The light from most galaxies was redshifted. This means the wavelengths of their light were stretched, making them appear redder than they should. This redshift is a cosmic version of the Doppler effect, the same effect that makes an ambulance siren sound lower in pitch as it moves away from you. Hubble found a remarkable relationship. The farther away a galaxy is, the faster it appears to be moving away from us. This observation, known as Hubble's law, or the Hubble-Lemaitre law, provided strong evidence that the universe is not static but is in fact expanding. It's not that galaxies are flying through a pre-existing empty space. Rather, the fabric of space itself is stretching, carrying the galaxies along with it. A common analogy is to imagine dots painted on the surface of a balloon. As you inflate the balloon, all the dots move farther apart from each other. No single dot is the center of the expansion. Every dot sees other dots receding. This expansion has profound implications. If the universe is expanding now, it means that in the past it must have been smaller, denser, and hotter. If you run the cosmic movie backward, everything converges to an incredibly hot, dense state. This is the essence of the Big Bang Theory, the idea that the universe began from an extremely energetic initial condition and has been expanding and cooling ever since. The discovery of the cosmic microwave background radiation, a faint afterglow of the Big Bang that permeates all of space, provides powerful supporting evidence for this model. Even more surprisingly, in the late 1990s, astronomers discovered that the expansion of the universe is not slowing down as might be expected due to gravity. Instead, it's accelerating. Some mysterious force, dubbed dark energy, seems to be pushing space apart at an ever-increasing rate. Dark energy is one of the biggest mysteries in modern cosmology. We don't know what it is, but it appears to make up about 68% of the total energy density of the universe. Understanding dark energy and the accelerating expansion is a major frontier in astrophysics today, pushing the boundaries of our knowledge about the ultimate fate of our cosmos. Section 9. The Unending Journey. Our Quest for Understanding. The universe, in its almost incomprehensible vastness and complexity, continues to be a source of profound wonder and relentless questioning. We have learned so much. We can measure distances in light years, we can identify billions of galaxies, we can study the birth, life, and death of stars, we can even detect planets orbiting distant suns. Yet, for all our advancements, we are constantly reminded of how much we still don't know. The observable universe is immense, but what lies beyond it? Is the entire universe finite or infinite? These are questions that still ignite the curiosity of scientists and dreamers alike. Our journey of cosmic discovery is far from over. In fact, it feels like we are just beginning to truly explore the depths of space and time. New telescopes, both on the ground and in space, are being designed and built with ever-increasing power and sophistication. Instruments like the James Webb Space Telescope are peering further back in time than ever before, capturing light from the very first stars and galaxies. Future missions will continue to probe the mysteries of dark matter and dark energy, search for habitable exoplanets, and perhaps even look for signs of life beyond Earth. Each new piece of data adds another piece to the grand cosmic puzzle. The quest to understand the universe is not just about accumulating facts and figures, it is about understanding our place within this vast cosmos. It is about recognizing the intricate connections between the largest cosmic structures and the smallest particles of matter. It forces us to confront fundamental questions about our origins, our existence, and our future. This pursuit of knowledge stretches our imagination, challenges our intellect, and ultimately enriches our human experience. The universe offers an endless frontier for exploration, a boundless source of inspiration for generations to come. So, how big is the universe? The answer is, it's mind-blowingly big, perhaps even infinitely so beyond what we can observe. But more important than any single number is the ongoing journey of discovery itself. We are a curious species, driven to explore and understand. As we continue to gaze out at the stars, let us do so with humility for what we don't know, and with excitement for all the wonders that still await us. The universe is a grand, unfolding story, and we are privileged to be a part of it, slowly learning to read its magnificent pages. The adventure continues.